Hey guys, welcome to our first instructional video provided by homeworkaholic.com. Visit our site at homeworkaholic.com to get free homework help. We showcase a problem dump containing a ton of sample homework problems with detailed solutions. If you have a problem you would like help with, you can select Post a Question for an expert to answer. In this video, we'll go in detail about how to solve a simple
separation of variables problem.
Going forward, we will frequently add videos that teach you how to solve problems posted by various users from our website. So to get started, here's a list of all the solutions that I've written, and we'll pick number 80, posted on August 7th. And here's the problem. So the problem basically asks you to find a solution to the differential equation presented here, and you're given a list of multiple choice solutions. So let's start by setting up our solution. So just follow up on this equation editor screen over here. I'm going to be typing a lot of things on here, and don't worry if you can't understand what I'm typing in. Just look down here to see the results. So here I'm just going to equation. So this is the original.
So when we're doing separation of variables,
what we basically want to do is move all the y terms to one side and all the x terms to the other side. And then we integrate each side separately. And that's quite easy to do here because we've already separated these terms for you. So what we want to do is somehow move dx to the right side and then move e to the negative 4y to the left side. So when we do that, we get this. So notice that all I've really done is multiply both sides by e to the 4y, because when you multiply e to the negative 4y times e to the 4y, you add the exponents, of course, and the exponents sum to 0, and anything raised to the 0th power gives you 1. So you basically remove e to the negative 4y from the right side. Moves to the left side with a positive exponent. And similarly, we multiply both sides by dx, and that appears on the right side. Okay. So now we're ready to integrate both sides. Okay, so all I've really done here is add the integral sign. And if you need some refreshers on how integrating works, you can go through our reference library. Oops. Here. Click on Mathematics. Click on Calculus. And then click on Integration Formulas. And there you go. We've got a list of integration formulas, including some that you probably wouldn't even need. So here what we only need is this third formula over here, so in case you need it. So here when we apply the formula and take the integral, we wind up with this. Now notice that I've added the constant terms because we're calculating indefinite integrals. And I used two different letters because the constants are not the same thing. However, if you realize that when you subtract two constants, you still end up with a constant. So what we can do is just effectively move one of the constants to the other side and just call it a constant. So that's what we can do here. And give it a different letter. Let's call it, I don't know. Let's just call it C again, even though we'll bear in mind that this C is not really the same thing as the C in the previous line. So all we did here is just subtract k from both sides, and because when you do so, a constant subtracting a constant still leaves you with a constant. Not to say that that constant cannot be 0. So this is essentially the form that our solution currently has. And now to remove the fractions, let's multiply both sides by 4. And when we do that, we left with this. And remember, our constant term isn't changed because that constant multiplied by a 4 is still going to give you a constant. So, next thing we want to do is just simplify the fraction. And there you have it. So let's go back to our question page to remind yourself of the multiple choices. And if you go through this list, you'll find, hey, matches with line H. So the solution is H. And if you go down here, you'll see the exact same. So if you have one of your own problems that you'd like us to help you out with, please do go to our website at homeworkaholic.com and click on Post a Question, and we'll be happy to help you out.